So we've talked about a quadratic function. We looked at the basic graph of it, but now we want to do a little more with the graphing. So let's start with one form of a quadratic function. F of x equals ax squared plus bx plus c. A, b, and c are numbers. Okay, so 3x squared plus 2x minus 5. Negative x squared plus 7x plus 3. It really doesn't matter what the numbers are. The one thing they tell you is a cannot equal 0, because if a equals 0, suddenly that's gone and it's not quadratic anymore. There are two other forms that we'll discuss before this unit is over, but for now we're going to look at standard. Now, yes, we previously talked about the shape of a square function. It's called a parabola, and it is a U-shaped graph. And one thing that's going to happen is sometimes the parabola opens up, sometimes it opens down. We're going to deal with the two cases, okay? So when a is greater than 0, a is positive. And when that happens, the parabola opens up. So the parabola will look like this. I'm going to tell you, just to really hammer this home, this is going to be a minimum value. When a is less than 0, a is negative, and when that happens, the parabola opens down like a frown. And when that occurs, we reach a high point here called the max. So far, I mentioned the terminology before. Now we looked at the two instances and the ways that the parabola can open. So when we talk about the max or the min, what we're actually referring to is the vertex. It's the lowest or the highest point on a parabola. The vertex is going to be the order pair HK. Now, this is my x coordinate, this is my y coordinate, but we're going to use H and K. It's something that's used in conic sections. It's used all throughout to show transformations. So it's one of those conventions that we use. When the vertex is the lowest point, it is called the minimum. It reaches its lowest point. Okay, when the vertex is the highest point, it is called a maximum. Okay, now we're going to go back to, I'm guessing, 6th grade, 5th grade math, I'm not sure, where we talked about a line of symmetry. Well, now that we're in uppity algebra 1, we call it the axis of symmetry. Let me make sure I spelled it correctly. The axis of symmetry is a vertical line that passes through the vertex, and it divides the parabola into two symmetric parts. And you write the axis of symmetry as x equals h. I'm going to tell you right now, it must be an equation. You can't just say 5. It's a line. So a line, remember, is the set of ordered pairs that satisfy a given equation. So please give me an equation for the axis of symmetry. So there are two formulas. Well, there's, you can just tell me x equals h, or you can, down the road, we're going to write it this way, where we're going to define, you'll see. Okay, so the axis of symmetry, keep those things in mind. So we introduced something new. Now let's review some old things, but we're going to use them in different ways. We've talked about the x-intercepts before. Those are the values of x when y equals 0. It's where the graph crosses the x-axis. We are going to refer to the x-intercepts sometimes as zeros. we'll say that what are the solutions? And when we get into upper level math, we actually call them the roots. And then the y-intercept, well, I guess I should put an S, even though remember, there's only one y-intercept in a function. That's the only way for it to pass the vertical line test. They're the values of y when x equals 0. And it's where we touch the y-axis. Okay? So I've given a description of the various parts of a parabola. Now I want you to see them in a graph. So let's start at the lowest point. The lowest point is here. This is my vertex. And in this case, it's a min. And by the way, 1, 2, 3, 4, 5, 6, 7, 8, 9. The min for this is -9. Okay, when we talk about the min or the max, we're talking about the y coordinate. So I would be remiss if I didn't mention that right away. So the next term that we discussed was the axis of symmetry. And we said that that actually goes through the vertex. So once you know the vertex, you know the axis of symmetry. So plot the axis, plot the vertex, and draw a vertical line through it. All right, next, let's look at the x-intercept. This actually has two of them. So this is my x-intercept, also known as a 0, also known as a solution or a root. And for this case, we have a 0 at 3. It's weird to say 0 equals 3, but it's a noun. 0 is 3. There's another one over here at 1, 2, 3, 4, 5, 6, 7, -7, 0, x-intercept of -7. And then my y-intercept is here. I want you to notice something here. Look at the two zeros. When I look at these two zeros, I notice that this 0 is 1, 2, 3, 4, 5 units to the right of the axis. Look at this 0. This 0 is 1, 2, 3, 4, 5 units to the left of the axis. Remember the BOGO points? That's the other cool thing in a parabola. See this point right here? It is 1, 2, 3, 4 units to the right. Well, if I know that this point is 4 units to the right, I could count 1, 2, 3, 4 units to the left and get a BOGO point. Because once I know this point here, I know that there is one point on the other side. Because remember, it's the axis of symmetry. That means that this thing folds onto itself. So keep that in mind as we go through. Okay? So we've talked about the standard form of a quadratic. We've noted the key features in a quadratic. Now I think what I want to do is talk about the other form of a quadratic function. And that is going to be the vertex form. Okay? So if you don't mind, I'm going to remind you of what the standard form is, because there's something very important here. Okay, see this A? It is the same value in both. And remember earlier I told you that whenever we talked about a vertex, we would use HK. Here it is. So what's going to happen here is we have x minus h, but my vertex is a positive h. We have plus k. My y coordinate is a positive k. All right, so keep those things in mind. Is there anything else I want to tell you about the vertex? We'll practice it when we look at these just to kind of keep everything together. But I would like to take a minute and go back to 8th grade math, namely 8th grade math unit 1. In 8th grade math unit 1, you dealt with a lot of geometry concepts. That included transformations, and that's what we're going to talk about today. So when a is negative, if there's a negative here, do you remember what happened? It took a function if it were up here and it reflected it down to the other side. So recall the reflections that you did in 8th grade math. We have a vertical stretch where if a is greater than 1, the absolute value of a is greater than 1, so this could be 5, this could be negative 5. Remember, it goes 5 times as tall. There could be a shrink where if we put 1/2 in here, then suddenly we're 1/2 as tall. In geometry, we refer to these as dilation, but in algebra, we call them a vertical stretch and a vertical shrink. Okay? The other ones you should remember is whenever we add to the x-coordinate, we're going to move everything to the left. When we subtract from the x-coordinate, we move everything to the right. When we add to the function, we move up. When we subtract, we move down. In 8th grade, we referred to these as translations, slides, and I keep spelling it wrong. Good grief. Translation. Okay, so remember that. Okay, so let's use this information and see if we can just write in words what our transformations are. So I'm going to remind you to how do I want to say it? Oh, use your order of operations. So order of operations tells me to go inside the parentheses first. So this is my first transformation. So what does this tell me to do? This tells me that we're going to translate left 3 units. Okay, so that's step 1. Then once we've squared, then we add. We're adding to the function. This says we're going to translate up 5 units. Okay. This function, so we go inside first. Remember, order of operations is do what's in the parentheses. So for this one, we're going to go right 2. Yeah, Robert, here that says subtraction. But remember, when you're inside, you do the opposite of what you think. Then notice after we square, we have to multiply by -1. And multiplying by -1 says that we reflect on the x-axis. And then finally, we add 7, which says that we're going to go up 7. All right, so y'all kind of get the idea here. All right, this one, again, we're going to go left 3. Then we multiply by 1/3. This is a vertical shrink of 1/3. We're only going 1/3 as high. And then we subtract the 2. That says we shift down 2. And then, number 4. Number 4, we go inside first. They added x to 2. That says that we're going to go left 2 units. Then we're going to, we're going to multiply by 4. So that is a vertical stretch by a factor of 4. But then there's a negative in front of it. So then we reflect on the x-axis. Now, could I do these in either order? Yeah, you could, because multiplication is commutative. Any order works. And then finally, we go up 8. Okay, so that's how transformations work. And see how these are in vertex form? I do kind of want to go off the page for a second. And I want you to be able to look at this and tell me what the vertex is. So bear with me here. When I look at this function, I know that my vertex is 3, 5. So you do the opposite of what's in here, which is 3, and then you bring over the 5. And I'll go ahead and tell you the axis of symmetry is x equals the x coordinate of the vertex. Over here, my vertex is 2, 7. You do the opposite of what's in here to get positive 2. You get a 7. And then my axis is x equals 2. The negatives in front don't matter. The numbers in front don't matter. All that matters is what's in the parentheses and what you add. So here my vertex is, instead of plus 3, we're going to subtract the 3. The y coordinate is negative 2. And my axis of symmetry is x equals negative 3. It's the x coordinate of the vertex. Here, my vertex is negative 2, positive 8. And my axis of symmetry is going to be x equals negative 2. Okay? All right, so now let's return to our program, shall we? So in the previous problems, I gave you a function and I asked you to give me the transformations. Now I'm going to give you the transformations and I want you to give me the function. And the parent function, the original function is x squared, okay? This is my parent function. I call it my OG, original graph. Okay, it's the parent. It's the one that everything is based on. Okay, so we look here and it says we're going to translate 3 units left. So that means that I'm going to take x plus 3. And then we're going to go 4 units down, which means that we subtract the 4. And that's it. I'm done. Now we're going to go 7 units to the right. Let's see. Going to the right means that we have a negative h, so we subtract the 7, and then we go 4 units up. And so that's what f of x is here. Excuse me. Now we're going to reflect over the x-axis. That means that a is negative, so we're going to have a negative number. So we're going to take x squared, we're going to go negative, and then we're going to go 3 units down. Okay? See, we didn't have to go left or right, so we didn't have to do anything to x before we squared it. So that's how I knew to just go straight into the x squared. Okay, we're going to reflect over the x-axis. Oh, now here we're going to translate 5 units to the right. So going to the right means that we subtract the 5. Let's go ahead and do the reflection. And then we go down 2 units. Okay. Vertically compressed by a factor of 1/3, then translated 8 units up. So there is no left or right change. That means we're going to just keep it as x squared. Multiply by 1/3 because that's a vertical compression. 8 units up says plus 8. All right, let's see this one. Vertically stretched by a factor of 2, reflected over the x-axis, then translated 4 units left. So if we're going to go left, that means we're going to add the 4 to the x. Stretch by a factor of 2, reflect over the x-axis. So that's it. Okay, so far so good? All right, so this isn't too bad. Now let's look at a couple more. Just a you try where, of course, I'm going to give you the answers to these. So, you can always pause it and try this. So it looks like here we're going to go left 3, and then up 4. Here, so we're not going left or right, but it looks like we stretch, and you really need to say a vertical stretch. My bad, I should have said that, not just written it, because there is a horizontal, but that's algebra 2. So there's a vertical stretch by a factor of 2. Then with the negative, that says that we have a reflection over the x-axis. And then we go down 3. So that one actually had 3 transformations. All right, transformations from the parent function are described. Write the equation. So we reflect over the x-axis. That means we're going to have a negative. 5 units left means we're going to add 5 to the x, and then 2 units up says we're going to add 2. So it looks like my function will be the negative of x plus 5 squared plus 2. And y'all, when I do word problems, I write, the information above it. Y'all seen me do that before. Why would it change for transformations? I mean, this description is in words. Let me convert the words to math, and then I'll work from there. All right. Suppose we are vertically shrunk by a factor of 1/2. That says multiply by 1/2. Translated 8 units right. That means that we're going to subtract. So this function will be 1/2 x minus 8. That whole quantity is squared. All right. So far, so good? Okay, so keep that in mind as we go through. Okay, Robodeer, that's great and all, but how does it look in a graph? Well, let's look at these one at a time. So I just want to warn you, I'm giving you the graph right now, and I'm going to want you to give me the equation. Guess what's going to happen eventually? I'm going to give you the equation. I want you to give me the graph. So when I go through this, I'm going to talk slowly, just for me, so that I don't confuse myself. Okay, so let's first notice the vertex. The vertex here is -2, 1. Okay, so right away, that's my h, that's my k. So h is -2, k is 1. And remember, your axis of symmetry goes through here. So my axis is x equals -2. That's where I'm going to start. Nothing crazy here. All I'm doing is picking out points and writing a line, or writing the equation of a line based on a point. Okay, now we need to discuss A. So remember when I first introduced parabolas, and I told you, let's do this. And I told you in a parent function, remember with just the standard parabola, when you start at the vertex, when you go to the right one, you'll go up 1. When you go to the right 2, you'll go up 4. When you go to the right 3, you'll go up 9. Remember, the vertical displacement is the square of the horizontal because it's x squared. Okay, so if I went 4 units to the right, 4 squared puts me at 16. If I went 5 units to the right, 5 squared puts me up at 25. So remember that. We have 1 to the right, takes us 1 up. 2 to the right, takes us 4 up. 3 to the right, takes us 9 up. 4 to the right, takes us 16 up, and so on, okay? So do I notice that pattern here? Dang, well, the first thing I notice is that A is negative because it's an upside down parabola, okay? But let's see what happens. When I go 1 right, do I go 1 vertically? Yeah, maybe I should use vertical and horizontal. Yeah. When I go 2 horizontally, 1, 2, 3, 4, I go 4 vertically. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when I go 3 horizontally, I go 9 vertically. So it does follow my pattern where A is 1. And in this case, A is -1 because it's upside down. So if I remember my vertex function or my vertex form, it's A times x minus h squared plus k. I'm going to plug that in right here. So I get f of x equals a, which is -1, x minus h is -2, oh dang, and then plus k. If I were to clean that up, I don't need the 1 here. I'm just going to bring down the negative. X minus -2 is x plus 2, and then I have my plus 1. Okay. P.S. Here I would have a maximum value, and it would be the y coordinate of 1. Just throwing that in because you're going to see it down the road. Let's go ahead and just kitchen sink this whole thing. What do I mean by that? We're going to throw in everything but the kitchen sink. Okay, let's look at number 12 here. Here is my vertex. My vertex is 4, -4. So h is 4, k is -4. My axis of symmetry is x equals 4. Let's go ahead and get that done. Okay, does this follow my standard vertex? If it follows my standard vertex, A is 1, or my parent. So we go to the right 1, up 1, right 2, 1, 2, 3, 4. Does this one do that? Yeah, it does. So A is 1. So for this problem, f of x is 1 times x minus 4 squared minus 4. And again, I'm not going to introduce that 1 if it's there. You know, I can bring it up, I can take it out. That's probably the easier way for me to do that one. And for this problem, it has a minimum value, and that minimum value is -4. Okay, so your max or your min is always the y coordinate of your vertex. Notice that happens here. I feel like I should write that somewhere, but we're going to see it again. All right. Let's look at number 13, shall we? So my vertex is, what is that? 1, 2, 3, 4, 5. 1, 2, 3. -5, -3. Do I follow my standard or my parent? Yes, I do. So A is 1. My axis of symmetry here is x equals -5. So I've got f of x equals x plus 5 squared minus 3. All right. Now let's look at the final one. My vertex here is -2, 2. My axis of symmetry is x equals -2. And my, A is going to be negative because it's upside down. So when I go to the right one, do I move down 1? No, I'm moving 2. When I move to the right 4, 1, oh, my bad. When I move to the right 2, 1, 2, 3, 4. Nope, 1, 2, 3, 4. So look what happens here. A is -2 because I have to go twice as much. So instead of going 1, 4, 9, it looks like I'm going 2, 8. I bet the next one will be 18 because we have to double our distance. So this one will be -2 times x plus 2 squared plus 2. And you know, look at this right here, y'all. If the function is x plus 2 squared, the axis is x equals -2. What's happening there? Well, we're basically setting what's being squared equal to 0. When you solve that equation, you get x equals -2. And look at that, that's my axis. Look up here. If x plus 5 equals 0, we're going to subtract the 5. X equals -5. There it is. Okay, look at this one. If we have the equation x minus 4 equals 0, adding 4 to both sides tells us that x equals 4. I see a whole bunch of stuff happening here. And since I'm throwing it all in, here my minimum value is -3 because the minimum occurs at the vertex. Here, my max is 2. That's my highest point. Dang, I'm throwing all kinds of stuff in here. Okay. So this is how you build an equation if I give you a graph. Okay. All right, now, how do we build a graph if I give you an equation? Well, you're going to find the vertex and you're going to plot it, okay? Find the axis of symmetry. You're going to graph this as a vertical line. Now, you can construct a table. Your calculator will find a table. You can plot points. Find 2 more points that are on one side. You're going to reflect those 2 points across the axis of symmetry. These are my BOGO points, y'all. You'll see. And then you'll make a U-shaped figure. So graph and identify the vertex and the axis of symmetry. Okay, so I'm going to do these out of order. I'm going to start with the easy ones. I'm going to start with 9, and I'm going to skip down to 12 because we increase in difficulty as we go. So let's knock these out just to see. Okay, so I have to identify the vertex and the axis. I can knock all that out right now. My vertex, you take the opposite of what's inside and you copy what's outside. And then I know my axis is x equals this x coordinate. The axis of symmetry is the x coordinate of your vertex. P.S. the max or the min is going to be the y coordinate. All right, but we'll save that for down the road. All right, let's see here. So I'm going to plot -2, 1. Let me move this up just a touch. I'm going to plot -2, 1. That's my vertex. I know I've got my axis of symmetry here. And now I need to construct a table and find 2 more points. Well, we can do that. I can do that off to the side. And you can see what happens when x is -1, 0, and 1 and plot those points. Or I can build what I know about my parabola, where when I move to the right one from the vertex, I go up 1. When I move to the right 2, I go up 4. And remember, I'm lazy. That's what I'm going to do. And because this is my axis, I know that if one point is 1 unit to the right, I get a free point 1 unit to the left. This point is 2 units to the right, so for free, I get the point 2 units to the left. And there it is. But I bet if you did the math here, if you plug -1 in there, you'll get 1 plus 1 is 2. If you put 0 in here, 0, 2 squared is 4, 4 plus 1 is 5. And if you substitute 1 in there, 9 plus 1 is 10. Do I see these points? Is -1, 2? There it is. 0, 5. There it is. Okay, so either way works. But I'm lazy, so I'm looking for shortcuts. Okay. Let's look at number 12, shall we? Okay, so I've got x minus 2 squared plus 3. So my vertex is 2, 3. My axis is x equals 2. So I'm going to plot 2, just kidding, 2, 1, 2, 3. All right, there's my vertex. My axis of symmetry, this is where I get my BOGOs. So from my vertex, right 1, up 1, right 2, 2 squared is 4. I could go right 3, then go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I could go there. And I may just put that there. Okay. So this point is 1 unit to the right. So for free, I get 1 unit to the left. This point is 2 to the right. For free, I get 2 to the left. This is 1, 2, 3 to the right. So 1, 2, 3 to the left. There it is. And check this out. Here's my minimum value. My minimum value is 3. It's the y coordinate here. For the previous one, my minimum was 1. And my y coordinate of my vertex was 1. Just throwing in this extra stuff, y'all, because I'm going to ask you about it down the road. So I need to make sure that you understand it. Okay. That way it's not a shock to you when I ask you questions. All right, so I thought about skipping around and doing the negatives next, but I think I want to show you a scale if you're okay with that. No. Let's go ahead and do the negatives. Let's go to number 11. I know that this is going to be upside down because I've got a negative here, so it's going to look like that. My vertex, I still find that the same way. Take the opposite of that and the copy of that. And I know that my axis is going to be x equals 1. So I plot the vertex 1, 2. And I make my line down the middle. Now I'm going to go right 1. I don't go up 1 because I have a negative. I'm going to go down 1. Then from the vertex, I go right 2. So I go down 1, 2, 3, 4. Okay. And then this is 1 unit to the right. So for free, I get 1 unit to the left. This point is 2 to the right. For free, I get 2 to the left. And listen, if you want to make a table and find all these values, please do. You know, pick -1, 0, and 1. Knock yourself out. But I bet if you work these out, you'll get the same points that I have. Because remember, work smarter, not harder. And let's go ahead and notice here we have a max of 2. And that's actually the y coordinate of my vertex. Let's look down here at number 14. Again, we're going to go upside down. My vertex is the opposite and the copy. Opposite of 3 is -3. Bring down -3. My axis is x equals -3. So I'm going to plot -3, 1, 2, 3, -3. That's my vertex. Then I have my dotted line here. And I'm going to, since A is 1, I'm just going to follow my standard pattern. Horizontal 1, vertical 1. Horizontal 2, vertical 4. If I want horizontal 3, I'd go vertical 1, 2, 3, 4, 5. Go vertical 9. Okay. This point that I created was 1 to the right, so for free, I get 1 to the left. This point was 2 units to the right, so my BOGO is 2 units to the left. This point is 3 to the right, so for free, I get 3 to the left. And there's my parabola. Okay. You know what? Let's go ahead and knock out number 13. There is a negative there, but it has a scale factor of 2. I think you're going to like this. My vertex is -4, 4. Opposite, copy. So -4, 1, 2, 3, 4. There's my vertex. My axis of symmetry is x equals -4. So I will be reflecting across this line. So Horizontal, 1. 1 squared is 2. 1 squared is 1. Okay, but notice I have a scale factor of 2, so I actually have to double that value. What, Robodeer? Yeah, exactly. So now look at the next one. A horizontal shift of 2 tells me to go vertically 4. 1, 2, 3, 4. But I have to do that twice because A tells me how many times. 1, 2, 3, 4. So what I'm doing is I'm making a skinnier vertex. It actually grows taller faster. Oh, dude, let me finish this. So if I have 1 point to the right, my BOGO is 1 point to the left. If this is 2 units to the right, my BOGO is 2 units to the left. And you know what? I feel like for this one, I should probably choose a few points for you. So let's look at f of -3. When you plot that, it'll be -2 times -3 plus 4 squared plus 4. You'll get 1, -2, -2 plus 4 is 2. There it is right there. Okay, and then you get that point for free. That's all I'm doing. And again, y'all, I'm showing you how the function is built. If you need to substitute, please substitute. FYI, the max is 4. My y coordinate of the vertex is 4. Okay. And then number 10. My vertex is 4, -1. So there's my vertex. My axis of symmetry goes through the vertex at x equals 4. So my parent function says right 1, up 1, but a is 2, so we actually have to double the square. Double the square. That's what I should have said earlier. My next point goes right 2. 2 squared is 4, but I have to do that twice. So I'm actually going up 8. And right 3, 3 squared is 9, but I have to double that. So I end up here. Okay, so I'm doubling the square. And again, my BOGO points, this is 1 to the right, so BOGO 1 to the left. 2 points to the right, BOGO's 2 points to the left. 3 to the right, BOGO's 3 to the left. And then I draw my parabola. And again, my minimum value is -1. That's the y coordinate of my vertex. Okay, so that's something I want to add here. The vertex tells you everything you need to know about a quadratic or the graph of a quadratic. The vertex, HK, it tells you that your axis of symmetry is x equals h, and then your max or your min, depending on how it opens, is k. Okay? So that's everything you need to know about graphing a quadratic. To graph it in standard form, find the vertex, plot some points, you get the other points for free. Sometimes I'm going to give you a graph, find the key points, and that helps you build the function. Please recall how you used transformations in 8th grade math, and that will help you build a function. So check this out. We built a function based on its graph. We built a function based on its description. I mean, that's pretty cool. And then we started with all of the different terminology that we began with graph analysis in Unit 2, but now we're focusing on the graph analysis of quadratics in Unit 3. And that's everything you need to know so far.